Hey you guys, let me tell you about relations and functions. Two important concepts, functions being where things should go. First of all, using the book, let's look in the glossary that a relation is the mapping between a set of input values, called the domain, and the set of output values called the range. So domain is one of those key words that I need you to understand, that we're talking about all of the numbers that we get to use that then can go into some sort of thing that tells them where to go. The mapping is a fun word. Like, we know what a map is. You look at it for directions. You pull up your GPS and it says, follow these paths. A mapping is our way in math of saying, take the information you have, use it to know where to go. These are all relations. So, for example, we have a collection of things, a set, and that collection of things of one, a two, the letter A, and a smiley face. We don't have to use numbers or letters. We can use symbols that we know. Those are all inputs. And because they're inputs, this arrow is what we say by the mapping. Follow the path from one to where it will lead you. So in my example here, one is gonna map to the square. Two is gonna map to the star. A is also gonna map to the star, and that's okay. A relation is just the arrows that connect inputs to outputs. Follow the path. The smiley face actually has two. It's gonna go from, from where it's located, it's gonna go to the square. But because this relation says we're gonna map, it will also go to the X. That's the inputs, and these are the outputs. One thing while I'm here, maybe I'll get back to it, pay attention to those two words, domain and range. We could also express a relation in a table form. So it's really taking the circles and it's turning them into a table just for organization. Sometimes you have a lot of information. You have a lot of input values or elements, and they need to be organized, and you want to keep track of them more simply than this picture that kind of gets like a spider web. It gets complicated. So here, the input is this column, and these are all of the input numbers that I used over there. 1, 2, a smiley face, and I actually smiley face written twice because there were two mappings from smiley face to square and from smiley face to X that I would miss if I didn't write smiley face down twice. So, 1 goes to square, just like the mapping over there. In fact, these are all their connected mappings based upon how we drew up the two circle items. Again, pay attention to the word domain and range. In fact, not only do we have to write a relation as the circular picture of how the arrows show connections, or in a table, we can even put them into this list of ordered pairs. So that's a brace. It's, the little like bump out nose. It's not like a parentheses, but more like a face in profile. But inside these are the coordinates, if you will, where we show the connected values and what they are, inputs connected to outputs. So like 1 and square, that's just like over here, the 1 and the square was mapped together. If we keep going, the 2 and the star, the A and the star, the smiley face with X and the smiley face with square have to be written twice. Those are three ways to represent relations. You could do it in a graph. You could also see it written in a table. But those are the ones that are gonna probably give you pause while you're taking a test or some sort of stressful setting. And I need you to know about those and don't be shook by them. So a follow-up after relation is the concept of function. All right, pin the video right here. Functions. What is a function? A function is a relation that carefully, that's the key thing that I added that the book didn't have, but I think it's necessary. I'll start over. A function is a relation that carefully assigns to each element of the domain exactly one element of the range. So I mentioned that you need to pay attention to the words domain and range, domain and range, domain, range, domain, range, domain, range, etc. So in that situation, I want to be more careful with how we connect and compare the items, in our relation, so that the domain elements are used once and they only go to one thing. We're going to answer the question back on that one. How do we turn that relation that I showed you into a function? Because right now, that example wasn't. These are all examples of functions. Ordered pairs. Just like a relation, ordered pairs help us identify the input to the output. So our domain elements all have a range element that they are connected to. So domain, range, domain, range, domain, range. We can see functions written as equations of y equals 2/3 x minus 1, where y is made up of range and x is made up of all of the domain elements. We can see these functions written in graphical form. So in graphical form, your x-axis is your domain choices, and the y-axis gives you options for the range, but sometimes there are numbers where the graph doesn't exist. So in this picture of the absolute value function, this absolute value function all opens up, and it has a lowest point at 0, for my example. No numbers smaller than 0 are allowed to be chosen as range because the graph doesn't go down to them. Domain is side to side, range is up and down, and you can see a function represented in a graph. We can also see functions represented in a table format. So I took the ordered pairs that were listed like that. Remember the brace opens and closes it. In the table form, I have our x input. I should have used input when I wrote this down, because this is just like what we did over there with relations. The x is the input, it's the domain, it's the independent variable, and then the y coordinates are the range elements that go with those x inputs. So like -2, 2, that was the coordinate right there. And it continued down, 0, 2, 3, -4, 1, 3. I know that table is a function and not just a relation because the x's are only listed once. Even though the y's are doubled up, the x's are listed once. That's the definition of a function. Each element of the domain is mapped to exactly one element from the range. Could be multiple times. And of course, I didn't want to leave away the circular representation of a function, a mapping. So you see here, -2 goes to 2, 0 goes to 2, 3 goes to -4, 1 goes to 3. It's mapped, I should say mapped instead. 1 is mapped to 3. If you're GPSing this, you're following the route from 1 to 3. But the thing that makes this a function is that we don't double up any of these domain numbers. If you double any of the domain numbers, for example, if right now I just magically produced a 0 as another member of the domain, well, we already have 0 in this domain. This 0 can't go to anything else other than 2. That would make it not a function. If I introduce a new element like a 5, and I say the 5 goes to 3, that would be okay. Multiple numbers in the range, like you can have 3 have multiple things connected to it, but if there's a number here in the domain, it goes to only one of them. So I have a couple questions. Let me go back to our relation question, and then I also want to spotlight some vocabulary. Okay, so here we go. Are any of these relations functions? Is this a function? No. That's my head nod for you, okay? Is the table a function? No. Are these coordinates functions? No. The question is why not? And I want to highlight right here. Smiley face is in the domain. Smiley face can only go to one thing. It can only be mapped to the other side with one arrow, but it has 2, which means if you're given smiley face, where does it go? Does it go to square or does it go to the letter X? And since we don't know, that's not a function. It's just a mapping. It's just a relation. So are any of these relations functions? There's 2 smiley faces. They go to different X and square outputs. There's 2 smiley faces. They go to different X and square outputs. No, none of them are relations. So I guess my follow-up question is, you get 2. How do you fix them? How do you fix the relation to make it a function? And honestly, legitimately going back over to that one, you would just pick your poison. Is the smiley face gonna go to square or is the smiley face gonna go to X? And once you identify what that is, we just nip that one, take it out, no longer an option. Smiley face is not gonna go to square. Smiley face is not gonna go to square. With that, let me leave you with the vocab words that we talked about. The important thing for you to recognize is that the concept of functions is an input, some sort of information has to follow a rule that changes it, and we get an output. And the input that's used will always go to the same type of output. If you put in a smiley face, you always get a square. If you put in a smiley face again, you always get that square. If you put a smiley face in and you get a letter X, like that example, it won't work. Last of all, domain, because the inputs, they're referenced as domains, and the outputs, they're referenced as ranges. Thank you for watching this video. Thank you for skipping your way through it if you needed to. I hope you got something from it. Of course, like, comment, and subscribe. Ask me for questions when you're in class with me, or leave me a comment in our Google Classroom, and I will see you in the next episode. Have a good one.